The Demon Core Incident. In the summer of 1945, World War II had just ended. The Manhattan Project was winding down, but scientists at Los Alamos were still playing around with plutonium cores, trying to understand exactly how close they could push these things to criticality before all hell broke loose. One of these scientists was a brilliant 24-year-old physicist named Harry Daghlian. On August 21, 1945, Harry was working alone in the lab late at night, which, spoiler alert, is already a terrible idea when you're dealing with a softball-sized sphere of plutonium that could go supercritical at any moment. Harry's experiment was simple in concept, but insane in execution. He was building a neutron reflector around the plutonium core using tungsten carbide bricks. Each brick he added would reflect more neutrons back into the core, pushing it closer and closer to a self-sustaining chain reaction. It was basically playing Jenga with the atomic bomb. He carefully stacked brick after brick, checking radiation levels as he went. Just one more brick, he thought. His hand moved slowly toward the core with the final brick and his hand slipped. The brick fell directly onto the plutonium core. Instantly, the core went supercritical. A brilliant blue flash filled the room as Cherenkov radiation ionized the air around the core. Harry felt the tingling sensation in his hand. That was massive amounts of radiation tearing through his cells. The room's radiation alarm started screaming. Now here's the horrifying part. Harry knew immediately what had happened. He knew he'd just received a lethal dose of radiation. He knew he was a dead man walking. But instead of running or panicking, he calmly knocked the brick off the core with his bare hand, exposing himself to even more radiation, because he knew if he didn't stop the reaction immediately, other people in the building could be hurt. The reaction stopped. Harry walked out of the room and calmly informed his colleagues what had happened. He even helped them reconstruct the accident for safety reports. Over the next 25 days, Harry Daghlian's body slowly shut down. His hand swelled to grotesque proportions. His white blood cell count plummeted. His organs began failing one by one. He experienced nausea, confusion, and unimaginable pain as radiation sickness destroyed him from the inside out. He died on September 15, 1945. But here's where it gets even more terrifying. Just 9 months later, another physicist named Louis Slotin died in almost the exact same way, with the exact same plutonium core. Scientists started calling it the Demon Core, a cursed sphere of plutonium that had now killed 2 brilliant young scientists. Slotin's experiment was even more reckless. He was manually holding 2 hemispheres of beryllium around the plutonium core using just a screwdriver to keep them separated. One slip of the screwdriver and the hemispheres would close completely, causing a supercritical reaction. His colleagues called it tickling the dragon's tail. On May 21, 1946, the screwdriver slipped, the hemispheres closed, another blue flash, another dead physicist. Slotin's last words as he lay dying were, "I'm done for." The Demon Core killed 2 men in less than a year before it was finally melted down and used in a nuclear weapon test. But the lesson remains. Some physics experiments are so dangerous that even the world's smartest people can't conduct them safely.
The Particle Beam Incident. Let's talk about Anatoli Bugorski. This story sounds like science fiction, but I promise you it's absolutely real. The year is 1978, Soviet Russia. Anatoly is a 36-year-old researcher working at the U-70 synchrotron, one of the largest particle accelerators in the world at the time. This machine accelerates protons to nearly the speed of light, creating a beam with unimaginable energy. On July 13, 1978, a piece of equipment malfunctioned. Anatoly went to investigate. Now, the particle accelerator should have had safety protocols that prevented the beam from firing while people were inside. Should have. This was Soviet Russia in the 1970s. Safety was more of a suggestion than a rule. Anatoli leaned over the malfunctioning equipment, putting his head directly in the path of the proton beam, not knowing the accelerator was still active. The beam fired. A stream of protons traveling at 99.99% the speed of light passed directly through Anatoli's head, entering through the back of his skull and exiting through his nose. The beam was only millimeters wide, but it carried more energy than a bolt of lightning concentrated into a space thinner than a human hair. Anatoli saw a flash brighter than 1,000 suns, but felt no pain. The beam had moved so fast and was so narrow that his nerves didn't even have time to register it. He calmly finished his work and went home, not telling anyone what had happened because he was terrified of what Soviet authorities might do to him for the accident. Over the next few days, the left side of his face began to swell grotesquely. The skin where the beam had entered and exited started to peel off. Doctors who examined him were horrified. They'd never seen anything like this. The proton beam had deposited an estimated 200,000 to 300,000 rads of radiation in a narrow channel through his brain. For context, 500 rads is usually fatal. Everyone expected him to die within days. But Anatoli didn't die. The beam had been so narrow that it only destroyed tissue in its direct path. The surrounding brain tissue was largely undamaged. However, the damage it did cause was permanent and bizarre. The left side of his face became paralyzed and never aged another day. If you look at photos of Anatoli today, the left side of his face looks exactly as it did in 1978, frozen in time like a grotesque snapshot, while the right side aged normally. He's essentially half mummified while still alive. He also lost hearing in his left ear, suffered from occasional seizures, and had to deal with chronic pain and fatigue. But against all odds, he completed his PhD, continued working in physics, and is still alive today. Anatoli Bugorski is the only human being ever confirmed to have been struck by a particle accelerator beam and survived. He's a walking physics experiment, proof that the human body can survive things it absolutely shouldn't be able to. But I don't think anyone's volunteering to replicate his experiment.
The Stanford Prison Experiment. Psychology meets physics of human behavior. Wait, hear me out on this one. In 1971, psychologist Philip Zimbardo wanted to study the physics of human behavior, how quickly ordinary people would transform under specific conditions and pressures. This wasn't chemistry or quantum mechanics, but it was absolutely an experiment in the physics of human systems. Zimbardo set up a mock prison in the basement of Stanford University's psychology building. He recruited 24 male college students, all psychologically healthy and stable, and randomly assigned them to be either prisoners or guards. The plan was to run the experiment for 2 weeks. The prison was designed to be as realistic as possible. Prisoners were arrested at their homes by real police officers, booked, fingerprinted, and brought to the basement prison. They were stripped, deloused, given uniforms, and assigned numbers instead of names. Guards were given uniforms, wooden batons, and mirrored sunglasses to prevent eye contact. Zimbardo wanted to see how social roles and environmental pressures would affect behavior. What he discovered was absolutely terrifying. Within 36 hours, the first prisoner had a complete mental breakdown. He began crying uncontrollably, screaming, and showing signs of severe psychological distress. Zimbardo and his team thought he was faking to get out of the experiment. He wasn't. The guards, who had been normal college students days earlier, began to sadistically abuse the prisoners. They forced them to do push-ups, denied them bathroom privileges, made them clean toilets with their bare hands, and subjected them to psychological torture. Some guards worked extra shifts voluntarily because they enjoyed the power. The prisoners began to show signs of severe depression, helplessness, and in some cases, total psychological collapse. They stopped referring to each other by names and used only their assigned numbers. They accepted their role as inferior beings. By day 6, the experiment had spiraled so far out of control that one of Zimbardo's graduate students, who he was dating at the time, came to observe and was horrified by what she saw. She confronted Zimbardo, who had become so absorbed in his role as prison superintendent that he'd lost all objectivity. He shut down the experiment immediately. Here's the terrifying physics at play. Zimbardo had discovered that human behavior operates like a state of matter. Change the environmental conditions, pressure, structure, power dynamics, and people transform from one state to another. Normal, healthy college students became sadistic torturers or broken, submissive victims in less than a week. The experiment was so disturbing that it fundamentally changed how we understand human psychology and led to major reforms in experimental ethics. Today, you couldn't legally conduct this experiment. It would be considered psychological torture. Zimbardo's findings explained how ordinary people become concentration camp guards, how torture happens in prisons, and how systems of oppression are maintained. The physics of human behavior, it turns out, is far more terrifying than radiation or particle beams, because it reveals that under the right conditions, any of us could become monsters.
The Philadelphia experiment, alleged. Okay, this one exists in a weird gray area between documented history and conspiracy theory, but it's too fascinating not to mention. The year is allegedly 1943. World War II is raging, and the U.S. Navy is supposedly conducting secret experiments in electromagnetic invisibility at the Philadelphia Naval Shipyard. The goal? Make an entire warship invisible to enemy radar, or, according to some versions of the story, completely invisible to the human eye. The ship in question was the USS Eldridge, a destroyer escort. According to the legend, scientists used massive electromagnetic generators to create an incredibly powerful electromagnetic field around the entire ship. The theory was based on Einstein's unified field theory, an attempt to link electromagnetism and gravity into one framework. On October 28, 1943, the generators were supposedly activated. What happened next depends on who's telling the story, but all versions agree something went catastrophically wrong. According to the most common version, the ship didn't just become invisible. It completely vanished in a flash of blue-green light. Witnesses claimed it teleported from Philadelphia to Norfolk, Virginia, over 200 miles away, was visible there for several minutes, then teleported back to Philadelphia. But the crew? The crew suffered fates worse than death. Some sailors were allegedly fused into the metal structure of the ship. Their bodies merged with the steel bulkheads at a molecular level, still alive but trapped in unimaginable agony. Some went insane instantly, screaming about things that weren't there. Others burst into flames. Some simply vanished and were never seen again. The survivors, if any truly existed, were said to suffer from severe mental illness, recurring invisibility, randomly phasing in and out of existence, and a condition where they would suddenly freeze in time, unable to move or speak while the world continued around them. Now here's the thing. The U.S. Navy officially denies this experiment ever happened. The ship's logs from that period show the USS Eldridge was nowhere near Philadelphia at the time. Most historians consider it a hoax or urban legend, possibly inspired by real degaussing experiments, which did make ships invisible to magnetic mines. But here's why it's still terrifying even as a legend. If even a fraction of this story were true, It would mean scientists attempted to manipulate fundamental forces of physics, electromagnetism, and possibly space-time itself with no understanding of the consequences. They would have treated reality like a toy, with human beings as expendable test subjects. The Philadelphia experiment represents humanity's ultimate hubris, the belief that we can control forces we don't understand. And whether it happened or not, it serves as a warning about what could go wrong when physics experiments escape the lab and into the real world, with real consequences. Some conspiracy theorists claim the experiment was part of Project Rainbow, which later became the basis for the MKUltra mind control experiments. Others say it was covered up to hide deaths and injuries caused by experimental electromagnetic technology. We'll probably never know the truth, but the legend persists because it touches something primal, the fear that scientists are conducting experiments so dangerous and unethical that they can never be revealed to the public. And sometimes, that fear is justified.
The Tsar Bomba test. October 30th, 1961. The Cold War is at its peak, and the Soviet Union is about to conduct the largest, most powerful explosion in human history. Not just the biggest nuclear test, the biggest explosion of any kind, ever, period. This is Tsar Bomba, and calling it a bomb is like calling the sun a light bulb. The device was designed by Soviet physicist Andrei Sakharov and his team to have a yield of 100 megatons. That's 100 million tons of TNT equivalent, or 6,500 times more powerful than the bomb dropped on Hiroshima. For comparison, every explosive used in World War II, including the 2 atomic bombs, combined with about 3 megatons. Tsar Bomba was designed to be 33 times more powerful than all of World War II. But even the Soviets realized they'd gone too far. They scaled it back to only 50 megatons because at 100 megatons, the bomb would create so much radioactive fallout that it would contaminate the entire Soviet Union and probably poison the entire Northern Hemisphere. Even at 50 megatons, this was an experiment in how much destruction humanity could unleash. The bomb was so massive, 27 tons and 26 feet long, that they had to specially modify a Tu-95 bomber just to carry it. The plane's bomb bay doors were removed entirely, and the bomb hung half exposed underneath the fuselage like a massive metallic tumor. On test day, the bomber took off with a crew who knew they might not survive. The bomb was equipped with a parachute to slow its descent, giving the plane time to escape. The calculations showed the plane needed to be at least 28 miles away from ground zero to avoid being vaporized. At the speed the plane could fly, this gave them about 250 seconds to get away after dropping the bomb. The bomber crew had about a 50% chance of survival. They knew this. They flew anyway. The bomb was dropped over the Novaya Zemlya archipelago in the Arctic Ocean. It detonated at an altitude of 13,000 feet. What happened next is almost impossible to comprehend. The fireball alone was 5 miles in diameter, so large that it nearly reached the ground despite detonating at 13,000 feet in the air. The flash was visible 600 miles away from Finland and Norway. The heat from the explosion could have caused third-degree burns to people standing 60 miles away from ground zero. The mushroom cloud rose to an altitude of 42 miles, 7 times the height of Mount Everest. The cap of the mushroom cloud had a diameter of 60 miles. The explosion was so powerful that atmospheric shock waves circled the Earth 3 times. Seismographs around the world registered the blast. The shock wave broke windows 560 miles away in Finland and Norway. The flash was so bright that one observer 170 miles away felt heat on his face and said his eyes hurt from the light. Everything within a 22-mile radius was completely annihilated. The ground was scorched and flattened. The intense heat literally vaporized everything organic. Buildings hundreds of miles away were damaged.
The pilot and crew miraculously survived, but the plane dropped over 3,000 feet instantly from the shockwave and nearly went out of control. Here's the most terrifying part. Tsar Bomba was deliberately designed to be a clean bomb. Most of its energy came from fusion rather than fission, which reduced radioactive fallout. It was almost like a humanitarian apocalypse weapon, if such a thing could exist. After the test, even Andrei Sakharov, the bomb's designer, was horrified by what he'd created. He spent the rest of his life as a peace activist and disarmament advocate, earning the Nobel Peace Prize in 1975. He later wrote that he felt a monstrous crime against humanity had been committed. The Tsar Bomba experiment proved that humans had gained the power to quite literally destroy civilization. We had created a weapon that could alter the Earth's atmosphere, trigger an artificial earthquake, and be visible from space. It was a physics experiment that demonstrated humanity had achieved the power of gods and the terrible judgment of children playing with matches. The Soviet Union never built another bomb this large. Neither has anyone else. Some things are too terrible even for weapons of war. But the blueprints still exist. The knowledge can't be unlearned, and that, perhaps, is the most terrifying legacy of all.
The Schrödinger's cat thought experiment, and real attempts. In 1935, physicist Erwin Schrödinger proposed one of the most famous thought experiments in quantum mechanics. It was designed to show how absurd quantum mechanics seemed when applied to everyday objects. Here's the setup. You put a cat in a sealed box with a radioactive atom, a Geiger counter, a vial of poison, and a hammer. If the atom decays, which is a quantum event, the Geiger counter detects it and triggers the hammer to break the vial, releasing poison that kills the cat. According to quantum mechanics, until you open the box and observe the system, the atom exists in a superposition, both decayed and not decayed simultaneously, which means the cat is simultaneously alive and dead until observed. Schrödinger thought this was ridiculous. He was trying to show that quantum mechanics, while it were great for subatomic particles, couldn't possibly apply to macroscopic objects like cats. The cat is either alive or dead, not both. But here's the terrifying thing. As far as we can tell, Schrödinger was wrong. Quantum mechanics really does work this way, even for large objects. The math says the cat genuinely exists in a superposition of alive and dead until observed. Now, obviously no one has actually conducted this exact experiment with a real cat. That would be monstrously unethical. But scientists have created quantum superpositions of increasingly large objects to test the limits of quantum mechanics. In 2010, scientists at UC Santa Barbara created a quantum superposition of a tiny metal paddle visible to the naked eye. The paddle was vibrating simultaneously and not vibrating at the same time. It was the largest object ever put into a quantum superposition. In 2019, researchers created quantum superpositions of molecules containing over 2,000 atoms. These weren't subatomic particles anymore. These were actual chunks of matter behaving according to quantum rules. The terrifying implication? There's no clear boundary where quantum mechanics stops and classical physics begins. In principle, you could put a cat or a person or the entire Earth into a quantum superposition. The math allows it. Some physicists, like those who support the many worlds interpretation, believe that Schrödinger's cat experiment, if actually performed, wouldn't result in a superposition at all. Instead, the universe would split into two branches, one where the cat is alive, one where it's dead. Both versions of reality exist simultaneously in parallel universes. Think about what that means for a second. Every quantum event, which happened trillions of times per second in your body, might be splitting reality into multiple branches.
There could be countless versions of you in parallel universes living slightly different lives based on quantum coin flips that happened in your neurons. Other interpretations are even weirder. The Copenhagen interpretation suggests that observation itself collapses the wave function, that consciousness plays a fundamental role in determining reality. You're not just observing reality, you're creating it. The terrifying thing about Schrödinger's cat isn't the cruelty to animals, it's what it reveals about the nature of reality. We live in a universe where objects can genuinely exist in multiple contradictory states simultaneously, where observation changes outcomes, and where reality itself might be constantly branching into infinite parallel versions. Quantum mechanics works. We've built computers, lasers, and MRI machines based on it. But we still don't really understand what it means. We've mathematically described a universe that doesn't make intuitive sense. And every experiment we conduct confirms that the universe really is that weird. Schrödinger's cat was meant to be a reductio ad absurdum, proof that quantum mechanics must be wrong because it leads to absurd conclusions. Instead, it became proof that reality itself is absurd. And that's more terrifying than any laboratory accident.
The Large Hadron Collider Black Hole Fear. March 2008. The Large Hadron Collider, LHC, at CERN near Geneva, Switzerland, is about to come online. It's the most powerful particle accelerator ever built, a 17-mile ring where protons will be smashed together at 99.999991% the speed of light, creating energies not seen since microseconds after the Big Bang. And people around the world are terrified that it's going to destroy the planet. The fear was simple. When you collide particles at these insane energies, you might create exotic particles that don't normally exist in nature. Some theoretical models suggested the LHC could create microscopic black holes. Now, theoretical physicists assured everyone that even if micro-black holes were created, they would evaporate instantly via Hawking radiation and pose no danger. But here's the problem. Hawking radiation has never been observed. It's a prediction based on quantum mechanics and general relativity, but we've never actually seen a black hole evaporate. What if Stephen Hawking was wrong? What if the LHC created a stable micro-black hole that didn't evaporate? It would sink to the center of the Earth and begin consuming matter, growing larger with each atom it absorbed. Within years, it would consume the entire planet from the inside out. Earth would collapse into a black hole the size of a marble. Several people filed lawsuits trying to stop the LHC from operating, arguing that scientists couldn't guarantee it was safe. One lawsuit claimed there was a possibility the experiment could create strangelets, hypothetical particles that could convert all normal matter they touch into strange matter, triggering a chain reaction that would convert the entire Earth into a dead lump of strange matter. CERN physicists released detailed safety reports explaining why these scenarios were impossible. They pointed out that cosmic rays hit Earth's atmosphere with far more energy than the LHC produces, and these natural collisions have been happening for billions of years without creating any planet-destroying black holes or strangelets. But here's the genuinely unsettling part. Before they turned it on, there was a non-zero possibility they were wrong. They were smashing particles together at energies never before achieved by humans, probing regions of physics where our theories become uncertain. They were confident it was safe, but confidence isn't the same as certainty. On September 10, 2008, they turned it on. The first beams circulated successfully. The Earth did not collapse into a black hole. Reality did not convert to strange matter. The universe continued to exist. But here's what keeps me up at night. We're still running experiments at the LHC, and we're planning even more powerful colliders.
The future circular collider, if built, would be 4 times more powerful than the LHC. We're continuously pushing into higher energies, probing deeper into the fundamental structure of reality. What if there's an energy threshold we shouldn't cross? What if at some point we collide particles with enough energy to create something truly dangerous? A stable vacuum decay bubble, a real stable black hole, or something we haven't even theorized yet? The terrifying thing about cutting-edge physics experiments is that, by definition, we're exploring regions where we don't know what will happen. Our theories make predictions, but theories can be wrong. Every time we build a more powerful accelerator, we're conducting an experiment with the entire planet as the laboratory, and all life on Earth as unwilling test subjects. So far, we've been lucky. The universe seems to have safety features built in, natural limitations that prevent the most catastrophic outcomes. But so far is the key phrase. We're running experiments that could, in principle, destroy everything. And we won't know for certain they're safe until after we've done them. Sleep well tonight.
The Starfish Prime nuclear test. July 9, 1962. The United States is about to detonate a nuclear weapon in space. Not in the atmosphere, not underground, in actual outer space. 250 miles above the Pacific Ocean. This is Operation Starfish Prime, and it's one of the most reckless physics experiments ever conducted. The Cold War logic went like this. If nuclear war breaks out, missiles will fly through space. What if we could destroy incoming missiles by detonating nuclear weapons in their path? Let's test it by nuking space and seeing what happens. The bomb was a 1.4 megaton thermonuclear warhead, about 100 times more powerful than the Hiroshima bomb. It was launched from Johnston Atoll in the Pacific on top of a Thor rocket. At exactly 11 p.m. local time, the warhead detonated 250 miles above the Pacific Ocean. What happened next shocked even the scientists who planned the experiment. The explosion created an artificial aurora that was visible across the Pacific, from Hawaii to New Zealand, over 4,000 miles away. The sky lit up with brilliant reds, greens, and blues as the bomb's radiation energized the upper atmosphere. People in Hawaii, 900 miles away, walked outside and could literally read newspapers by the light of the explosion. But the pretty lights were the least of the problems. The explosion generated an electromagnetic pulse, EMP, far more powerful than anyone had predicted. This pulse of electromagnetic radiation fried electronics across Hawaii. Streetlights went out. Burglar alarms started ringing spontaneously. Phone lines went dead. Cars stalled in the streets. But it got worse. The explosion also damaged or destroyed at least 8 satellites, about 1/3 of all satellites in low Earth orbit at the time. The British satellite Ariel 1 failed immediately. Several U.S. satellites stopped functioning. The radiation belts created by the explosion persisted for years, damaging additional satellites long after the test. Scientists had created artificial radiation belts around Earth, regions of space filled with high-energy particles trapped by Earth's magnetic field. These artificial belts were more intense than the natural Van Allen belts and posed a radiation hazard to astronauts and satellites for years afterward. Here's the most terrifying part. Nobody really knew what would happen before they did it. The scientists had rough calculations and educated guesses, but they were detonating a nuclear weapon in an environment where nuclear weapons had never been detonated before. They were experimenting with Earth's magnetosphere, the protective bubble that shields us from cosmic radiation. What if the explosion had damaged the magnetosphere permanently? What if it had triggered a runaway cascade that stripped away Earth's magnetic field? We'd be bombarded with cosmic radiation that would make the planet uninhabitable. They didn't know. They took the risk anyway. After Starfish Prime, the U.S. conducted several more high-altitude nuclear tests before the Limited Test Ban Treaty of 1963 banned nuclear weapons testing in space, the atmosphere, and underwater. The Soviets conducted similar tests with similar results. Today, Starfish Prime is remembered as a cautionary tale. We took our most powerful weapon and detonated it in an environment we barely understood with consequences we couldn't fully predict. We experimented with planetary-scale forces as if Earth were a laboratory rat. The fact that we're still here, that we didn't permanently damage Earth's magnetosphere or create runaway effects that destroyed the planet, is more luck than wisdom. And the terrifying reality is that all the knowledge still exists. The calculations, the blueprints, the data, it's all still there. Any nation with nuclear weapons and rockets could, in principle, repeat these experiments. We've shown that humans have the power to conduct physics experiments that could alter Earth's protective systems, damage the space environment, and create effects visible across thousands of miles. We're still living on the same planet we nearly broke in 1962. The experiment succeeded in a narrow sense. It proved we could nuke space. But in a broader sense, it proved something more disturbing: that humanity will conduct almost any experiment, no matter how reckless, if we think it gives us a military advantage.
The Trinity Test. First atomic bomb. July 16, 1945. 5:29 a.m. The Jornada del Muerto Desert in New Mexico. The Journey of Death. The most significant physics experiment in human history is about to begin, and the scientists conducting it aren't entirely sure it won't destroy the world. This is the Trinity Test, the first detonation of a nuclear weapon. Leading up to the test, some of the world's smartest physicists were genuinely concerned about worst-case scenarios. Physicist Edward Teller had calculated a small but non-zero probability that the atomic explosion could ignite Earth's atmosphere in a runaway fusion reaction, turning the entire planet into a miniature star and incinerating all life instantly. Think about that. They calculated the odds of destroying all life on Earth, decided those odds were acceptably low, and proceeded with the experiment anyway. Other scientists worried the explosion might ignite the oceans, trigger massive earthquakes, or create a chain reaction that couldn't be stopped. Nobel laureate Enrico Fermi, always the practical jokester, started taking bets on whether the bomb would merely destroy New Mexico or wipe out all life on Earth. Project director Robert Oppenheimer later admitted he'd been terrified in the hours before the test. Not just nervous, genuinely afraid they might be about to commit an act of cosmic arrogance that would end humanity. The bomb itself, nicknamed the Gadget, was a plutonium implosion device sitting atop a 100-foot tower. Its yield was estimated at around 5 to 20 kilotons, but nobody knew for sure. This was the first of its kind. There was no previous experiment to compare it to. At 5:29:45 a.m., the bomb detonated. A flash of light brighter than a dozen suns illuminated the desert. Observers 10 miles away felt the heat on their faces, like opening an oven door. The fireball expanded to over 600 feet in diameter, vaporizing the steel tower instantly. The temperature at ground zero exceeded 7,000 degrees Fahrenheit, hotter than the surface of the sun. The shock wave flattened buildings at the base camp. The mushroom cloud rose 7.5 miles into the air. Windows shattered 120 miles away. The explosion was felt as far as 160 miles away, where residents thought it was an earthquake. The blast converted sand into a new form of glass, later named trinitite, a greenish glassy substance created when sand melted and fused together in the intense heat.
It's still radioactive today. But the atmosphere didn't ignite. The oceans didn't catch fire. The Earth kept spinning. Oppenheimer later said that as he watched the explosion, a line from Hindu scripture flashed in his mind. "Now I have become death, the destroyer of worlds." Another scientist, Kenneth Bainbridge, turned to Oppenheimer after the test and said simply, "Now we are all sons of bitches." The Trinity test proved that humans had unlocked the fundamental forces of nature, the same forces that power the sun and stars. We had reached into the atom and torn it apart, releasing energies that had been locked away since the formation of matter itself. But here's what makes Trinity truly terrifying as a physics experiment. The scientists proceeded, despite knowing there was a chance, however small, that they could destroy everything. They calculated the probability of atmospheric ignition, concluded it was unlikely, and pressed ahead anyway. This wasn't reckless stupidity. These were brilliant minds who understood the stakes. But they were also conducting this experiment during World War II, in a race to build the bomb before Nazi Germany did. The calculation wasn't just about physics, it was about geopolitics, about preventing an even worse outcome if Hitler got the bomb first. But imagine being in that control bunker, watching the countdown, knowing that in a few seconds you'd either have successfully conducted a revolutionary physics experiment or accidentally destroyed all life on Earth. Imagine pressing that button. The Trinity test opened Pandora's box. Within weeks, atomic bombs would destroy Hiroshima and Nagasaki. Within years, the Soviet Union would have their own atomic weapons. Within decades, the world would have enough nuclear weapons to destroy civilization dozens of times over. We can never go back. The knowledge can't be unlearned. Every nation that acquires the scientific and industrial capability will eventually build nuclear weapons. The genie can't be put back in the bottle. Trinity proved that humans had become gods, capable of harnessing the fundamental forces of the universe. But it also proved we're gods without wisdom, running experiments that could destroy us before we fully understand the consequences. The desert where Trinity detonated is still contaminated with radiation 80 years later. Trinitite is still scattered across the sand. The crater is still there. It's a permanent scar on the Earth's surface, a reminder of the day humanity conducted the most dangerous physics experiment in history and survived. Barely. But next time, we might not be so lucky. And that's all for now. I don't know why you enjoy learning about physics experiments that could literally end the world, but here we are. Science isn't always about progress and discovery. Sometimes it's about seeing how close we can get to annihilation before someone says, maybe we should stop. Have a happy day, and maybe think twice before pressing any buttons in physics labs.